Okay, let's dive in. Imagine a digital currency, right? But one that's specifically designed to get rarer over time. The idea being, well, to potentially increase its value.
Exactly. We're talking about the AERE token today and the AERE network it runs on, which is built on Harmony 1.
And we want to get past the headlines and really dig into the nuts and bolts.
Yeah.
What makes AERE tick?
Right. We've got some good source material here, details on the token, the network itself, its economic model, the tokenomics, and even a technical look under the hood.
So our mission today is to pull out the key stuff, the interesting bits for you. Basically, a shortcut to understanding AERE's fundamentals and what it might mean without you having to read all the dense docs.
Sounds good. Where shall we start? The token itself.
Yeah, let's start there. What is AERE, fundamentally?
Okay, so AERE is the native token, the fuel for the AERE network.
And the network is?
It's set up as an enterprise-grade public blockchain, built using Harmony One's tech as a base.
Gotcha. And supply. Is there a limit?
Yeah, a hard cap. Maximum of 2.1 billion AERE tokens will ever exist.
Okay, 2.1 billion. But you mentioned something key right at the start. Deflationary.
Exactly. That's a big part of its design. It's engineered to become scarcer over time, not inflate.
Right, deflationary. So the total number of tokens is meant to actually decrease.
Yeah.
How does that work? How do they make the supply shrink?
Well, it's got a couple of mechanisms working together. First, there's an automatic burn.
A burn mechanism.
Yeah.
Yeah.
Based on the info we have, up to 50%, half of the fees from every transaction on the network gets permanently destroyed, taken out of circulation forever.
Up to 50%. Wow. So just using the network actively reduces the supply.
Precisely. The more activity, the more tokens get burned. It's different from, some chains where fees just go to miners or validators. Here, a chunk just vanishes.
Okay, that's pretty direct. Tied straight to usage. But I think I read there's something else too.
Yeah.
Something inspired by Bitcoin.
You got it. It also uses halving events, just like Bitcoin.
Halving. Explain that quickly.
So the rewards paid out for mining new blocks, creating new AERE, get cut in half periodically.
Okay.
For AERE, this happens every 125 million blocks. Right now, the reward is 1.25 AERE per block.
And the next one is?
According to the sources, it's expected in about 12 months from the time this info was current.
So like Bitcoin, the rate new tokens are made slows down predictably over time. And didn't it start much higher?
Oh, yeah. The sources mentioned phase 1 rewards were 16 AERE per block, so it's already halved quite a bit.
16 down to 1.25 now, heading lower later.
Right. And this halving schedule continues through different phases, putting another brake on new supply. And what's interesting is it's not just transaction fees and mining rewards affecting supply.
What else?
A percentage of the trading fees from their own built-in decentralized exchange, their dApps, also gets burned, plus fees from any third-party services integrated into the network.
Ah, so it's like multiple streams feeding into this burn mechanism.
Exactly. Transaction fees, DFX fees, third-party fees, all contributing to reducing the total supply. It's a multi-pronged approach.
Okay, that makes sense. A dual engine, burning fees from usage and having the creation rate. Let's talk about that creation, the mining. How does that work if it's not like Bitcoin's energy-heavy method?
They call it a sustainable subscription-based mining protocol.
Subscription-based.
Yeah, the detail suggests it's designed to have a lower environmental impact than, say, traditional proof-of-work mining. Users likely subscribe to access mining capabilities.
Interesting. And most of the tokens come from this.
The vast majority. 2 billion out of the 2.1 billion total supply are set aside for these mining rewards over time.
What about the other 100 million?
That was an initial pre-mint. The sources say it was allocated for things like marketing, getting listed on exchanges, and providing that initial bit of liquidity so people could actually trade it.
Right, sort of bootstrapping the whole ecosystem. Makes sense. So, okay, you can get AERE through this subscription mining or buy it. Once you have it, what can you actually do with it? What's its purpose?
It has several core uses. First off, it's what you use to pay gas fees.
Like Ethereum gas.
Exactly. Any transaction, any smart contract interaction on the AERE network, you pay the fee in AERE. And remember,
Part of that fee gets burned.
right.
Reinforcing the deflation.
Yep. Second big use, DAO governance. Holding AERE gives you voting power.
DAO. Decentralized Autonomous Organization.
Right. Your voting power is proportional to how much AERE you hold. So holders get a say in the network's future.
How much say? Is there a threshold?
Yeah, to actually submit a formal proposal for a change, you need to hold at least 1 million AERE, according to the documents. But for voting, it seems like 1 AERE equals 1 vote.
Okay, so real influence for significant holders, but everyone can participate in voting.
Yeah.
That's pretty standard for DAOs, but good to know the specifics. What else? Beyond gas and governance.
Well, there's the whole DeFi angle, decentralized finance.
Like staking.
Lending.
Both. You can stake your AERE. The sources mention an 8.2% APY, annual percentage yield, with a minimum stake of just 100 AERE.
8.2% APY, not bad. You can also provide liquidity on decentralized exchanges, like their own internal DX. The example given is the AERE USDC pair potentially earning up to 24% APY, though, APYs like that can fluctuate a lot.
Sure. Always comes with risks and variability.
Yeah.
But it's an option. Collateral, too.
Yeah, it can be used as collateral in DeFi lending and borrowing protocols. And one more kind of unique thing.
Go on.
It's used to access premium tiers for their mining bots. Remember the subscription mining?
Ah, right. So holding or paying with AERE gets you better mining access.
Seems like it's tied to the subscription costs, which are priced in USDC but likely connected to AERE somehow, or maybe holding AERE gives discounts. The price ranges mentioned are like 65 USDC a month for 2.5 terahashes per second, up to 2,000 USDC a month for 100 terahashes.
Okay, so it's deeply integrated. Gas, governance, DeFi, even access to the mining service itself. It's a functional token within its own world.
Definitely.
So if someone listening is thinking, all right, I'm curious, how do I actually get some AERE? What are the paths?
Well, the most direct way is probably buying it on a centralized exchange, or CEX. The sources mention using USDT, the stablecoin.
Standard enough.
Then there's the subscription mining service we talked about. And finally, they have the AERE bridge.
A bridge for moving assets.
Exactly. Allows you to transfer tokens from other compatible blockchains onto the AERE network. So if you have assets elsewhere, you could potentially bridge them over and swap for AERE within the AERE ecosystem.
Okay, buying, mining via subscription or bridging assets in. Yeah, so that covers the token, but it all runs on the AERE network. What's the big picture for the network itself? You said enterprise grade.
Yeah, that seems to be the key focus. It's positioned as a blockchain built for business needs. Emphasis on speed, security, and scalability, things enterprises really care about.
So not just another general purpose chain, but tailored for business use cases.
That's the message coming through the sources, yeah.
And what technical features back that up? What makes it enterprise grade?
Several things stand out. First, performance. They claim their high-performance DX can handle up to 2,000 transactions per second.
2,000 TPS, that's pretty high.
And crucially, 2-second finality,
Yeah.
meaning transactions are confirmed like really fast, near instant.
Okay, speed is definitely important for business. What else?
Big one, EVM compatibility. It's fully compatible with the Ethereum virtual machine.
Ah, so Ethereum developers can jump right in.
Pretty much. They can deploy their existing smart contracts, use familiar tools. It hugely lowers the barrier for developers and projects to come over from Ethereum.
That's a massive advantage. Anything else technical?
They also highlight cross-chain interoperability using native bridges, making it easy to move assets between AERE and other chains. And of course, a multi-layered security approach, though details there are a bit high-level in the overview docs.
Right. High TPS, fast finality, EVM compatibility, bridges, security. Sounds like a solid foundation. What kind of specific real-world uses do they envision for this network?
The documentation paints a pretty broad picture. In DeFi, think high-speed DELXs, efficient lending borrowing, cross-chain asset management.
Okay, standard DeFi stuff, but faster, maybe cheaper.
Potentially. For enterprise solutions specifically, they talk about private transactions using zero-knowledge proofs, that's advanced privacy tech. Also, things like customizable multi-signature governance for businesses and decentralized identity solutions.
ZK proofs and multisig. That does sound enterprise-focused.
Then there's gaming and NFTs. They mention gasless transactions, which would be huge for games, and cross-chain NFTs moving your digital collectibles between different blockchains.
Gasless or near gasless. Big difference, but appealing either way for high-volume game interactions.
The source mentions gasless transactions, but sometimes that means fees paid by someone else or very, very low. We'd need deeper specifics. Also, payments, instant cross-border stuff, micropayments enabled by the speed and low cost,
It makes sense.
and even IoT Internet of Things and supply chain, using the blockchain for secure device communication or tracking goods in real time.
Wow, okay. That's ambitious. Covering DeFi, enterprise, gaming, payments, IoT. They're aiming wide.
Seems like it, trying to be a foundational layer for a lot of different applications.
Let's peek under the hood then, like you mentioned. What's the actual architecture? You said multi-layered.
Yeah, think of it like a tech stack. There's an execution layer where the transactions actually happen, a consensus layer where everyone agrees on the transactions, data availability layer, making sure the data is accessible, settlement layer for finality, and the base network layer for communication.
Okay, different jobs, different layers. Makes sense. And nodes, different types.
Yep. Validator nodes are the ones doing the consensus work, staking AER. Full nodes keep the whole history. Light nodes let users interact without downloading everything. And archive nodes store even more historical data for specific needs.
Right. Now, the sources mentioned sharding for performance. Can you break that down?
Sure. Sharding is basically splitting the network's workload. Instead of one big chain processing everything in sequence, you divide the network into multiple smaller chains, or shards.
Like lanes on a highway.
Exactly like that. Each shard processes its own set of transactions in parallel. So if you have, say, 4 shards, you can potentially handle 4 times the transactions compared to a single chain. It's a key technique for boosting throughput.
And that's how they get to that 2,000 TPS number, presumably.
That, combined with their consensus mechanism, yeah, it's a core part of their scaling strategy. The docs even mention specific network topologies like mesh and tree structures for how these shards communicate efficiently.
Got it. Parallel processing via sharding. Now, how do they all agree on what's valid? The consensus mechanism, you said, enhanced proof of stake, EPOS.
Right. Enhanced proof of stake. It builds on Harmony One's consensus, but with their own tweaks.
What kind of tweaks?
Things like fair validator selection based on stake, but maybe with mechanisms to prevent too much centralization. Slashing penalties are key validators get punished financially if they misbehave, like trying to double sign a block, or even if they're offline for too long.
Keeps them honest and online.
Supposedly. It also supports delegated staking, so if you hold AERE but don't want to run the hardware yourself, you can delegate your stake to a validator and still earn rewards.
Common feature, but good to have. And how is a block finalized? When is a transaction irreversible?
It requires signatures from at least 2/3 of the active validator set for a block to be considered final.
2/3 majority. That sounds pretty secure.
It's a common threshold in POS systems, aiming for a strong guarantee against invalid transactions getting confirmed.
And this EPOS and sharding combo gets them that 2-second finality we talked about.
That's the idea. The parallel processing from sharding, plus an efficient consensus round within each shard, allows them to reach agreement and finalize blocks very quickly.
Impressive speed. Okay, so layer 1 scaling is sharding, but you mentioned layer 2 earlier as well. What's the plan there?
Yeah, they're not just relying on sharding, they're also supporting and exploring layer 2 solutions. These run sort of on top of the main AERE chain to handle even more transactions, often at lower cost.
Like what? What kind of layer 2s?
The sources specifically mention optimistic rollups. These bundle lots of transactions together off-chain and post a summary to layer 1. They have a challenge period. The example given was 7 days where anyone can flag fraud.
Optimistic, because you assume it's valid unless challenged. What else?
ZK rollups, zero-knowledge rollups. These use complex math zero-knowledge proofs to prove the validity of the off-chain transactions without revealing the data itself. Generally faster finality than optimistic rollups, but more computationally intensive.
VK Tech is definitely cutting edge. Anything else?
They're also looking into state channels. These are more for direct, high-frequency interactions between a few parties, like in a game or payment channel. Most activity happens off-chain, only settling on the main chain periodically.
Okay, so a mix. Sharding on layer 1, plus optimistic rollups, ZK rollups, and state channels as layer 2 options. That's a pretty comprehensive scaling strategy. Thinking ahead.
Seems like it, covering different bases for different needs.
What about building on EO? We know it's EVM compatible, which is huge. What tools do developers get?
Because it's EVM compatible, they get the whole familiar Ethereum toolkit. Solidity language for smart contracts.
The standard, yeah.
Popular tools like Hardat, Truffle, Remix for development and testing, standard libraries like Web3.js, Ethers.js for connecting apps to the blockchain. It should feel very familiar to anyone who's built on Ethereum or similar chains.
Makes adoption much easier for devs.
Ah.
Smooth transition.
Okay.
And costs.
Yeah.
Gas fees. We know some get burned, but are they generally high or low?
The model is like Ethereum's pay for computation. But the sources emphasize that the actual cost on AERE is significantly lower than on Ethereum mainnet.
Lower fees are always attractive.
Yeah.
And burning part of it adds that deflationary aspect we discussed. Interesting dynamic.
Yeah, it serves both to manage network resources, prevent spam, and contribute to the token's scarcity.
Right. Now, connecting to other blockchains interoperability, you mentioned the AERE bridge. What does it connect to?
The AR bridge specifically connects to other EVM-compatible chains, so think Ethereum, Binance Smart Chain, Polygon, Avalanche, C-Chain, etc., allows asset movement between these major ecosystems.
Okay. Good coverage of the EVM world. Any plans beyond that?
Yes, they also mention implementing the Inter-Blockchain Communication Protocol, IBC.
Ah, the Cosmos standard. That would open up connections to a whole different set of chains.
Exactly. Chains within the Cosmos ecosystem and others adopting IBC. That would significantly widen their interoperability reach. They also mention integrating decentralized oracles for bringing real-world data onto the chain.
Oracles are crucial for many advanced smart contracts. So bridges for EVM, IBC plan for wider reach, plus oracles. Sounds like they're serious about connectivity.
It appears so, aiming to be a connected player, not an isolated island.
Let's talk security fundamentals. How does AR protect itself?
It's layered. The EPO's consensus itself helps against Sybil attacks, one person pretending to be many. The slashing conditions we mentioned are a big economic deterrent for bad behavior by validators.
Right, making it expensive to cheat.
They also use verifiable random functions, VRFs, for secure randomness, which is important for things like fair validator selection, and standard stuff like continuous network monitoring to spot issues early.
Seems like the standard suite of POS security measures, which is reassuring.
Yeah.
Okay, one last technical area, governance,
Yeah.
the DAO. How does it actually work on-chain?
It follows a pretty clear process outlined in the sources. Someone holding enough AR, that 1 million threshold, submits a formal proposal.
Okay.
Then there's a discussion period for the community. After that, AR holders vote 1 token, 1 vote.
Simple enough.
For a proposal to pass, it needs to meet certain criteria like enough people voting, quorum, and a sufficient majority saying yes.
And if it passes?
The implementation can often be automated via smart contracts. The DAO can control protocol upgrades, manage treasury funds, basically steer the network's evolution based on holder votes. The rules, like voting periods and thresholds, are all defined in the protocol.
So a structured way for the community to manage the network over time.
Right.
And the roadmap suggests they're still actively building.
Definitely. The roadmap mentioned looking at Q3 2025 for optimizing how shards talk to each other and implementing ZK rollups.
Okay, scaling focus.
Q4 2025 aims for state channels and expanding interoperability further.
More scaling and connectivity.
And then looking out to Q1 2026, they're even starting research into quantum resistance, planning way ahead for potential future threats from quantum computing.
Quantum resistance research already. That is forward thinking. Okay, this has been really comprehensive. Let's try to boil it down. What are the absolute key takeaways about AR?
I'd say it's this. AR is a crypto designed for increasing scarcity through burns and halvings. It powers an enterprise-focused blockchain built for speed and scale using sharding and layer 2s.
Built on Harmony One tech, EVM compatible.
Right. Strong focus on performance, security, and developer friendliness via that EVM compatibility, and utility across DeFi, governance, and even access to its own mining system.
And aiming for broad application, DeFi, enterprise, gaming, IoT, governed by its token holders via DAO.
That sums it up pretty well. It combines that deflationary economic model with a high-performance, enterprise-ready technical foundation.
Okay, so for you listening, here's something to chew on. You've got these deflationary tokenomics, the burns, the halvings, combined with a network built for serious enterprise-level speed and capability.
Yeah, it's an interesting mix.
So what kind of long-term impact does something like AER have on the wider blockchain world, or even how you might interact with this tech down the line? Does putting those two things together, scarcity and enterprise focus, unlock possibilities we haven't really seen play out yet?
Definitely food for thought.
Absolutely. If this sparked your interest, we definitely encourage you to check out the resources mentioned in our sources, the white paper, the Network Explorer, and keep exploring the AER ecosystem yourself.